Okay, when you think about, like, truly iconic synth sounds,
Yeah.
the ones that just define tracks,
Yeah.
so many of them, you can pretty much trace right back to this one instrument,
Yeah.
the Minimoog Model D.
Oh, absolutely. It's legendary for a reason. Before the Mini, synths were these enormous things stuck in labs, weren't they?
Totally. Huge, complex beasts. The Minimoog, though, it just changed the game around 1970. Suddenly, musicians could take that synth power on stage.
And it wasn't just smaller, was it? It was designed for players. That whole layout, no patch cords needed for the basic stuff. It was intuitive, immediate.
Exactly. Forget the patching nightmare. It gave you this direct way to sculpt sound that just hadn't been there before.
Yeah, real instrument feel.
And that's what we're going to get into today. We're doing a deep dive into the Minimoog sound, like what makes it tick, and how you actually program it, using the manual as our guide.
Sounds good. And looking at that front panel, it really is like a roadmap for synthesis, isn't it? It makes sense visually.
Yeah, it flows. You've got the controllers, oscillators, modifiers.
Yeah.
It shows you how the sound gets made.
Right. You start with the sound sources, mix them, shape them. That linear thing is, I think, why it was so revolutionary and easy to grasp.
Okay, let's jump into the sound sources then. The oscillator bank. The heart of the voice, right? 3 oscillators.
Yep, 3 independent sound generators. And the first big control for each is that range knob.
Gives you the basic pitch, 5 octaves.
5 octaves, plus that crucial low setting. Don't sleep on the LO setting.
Ah, right, for modulation. Takes it way down low.
Exactly, below hearing range. So you can use it as a low-frequency oscillator, an LFO, to make things wobble or shift over time. Super useful.
Okay, cool. Now, oscillators 2 and 3, they have those frequency knobs. They're not just for tuning, are they? There's more
Oh,
to it.
yeah, much more. That's where you get the richness. Detuning OSC 2 or 3 just slightly from OSCE 1.
Creates that classic fat chorus sound.
You got it, that swirling movement. But you can also tune them to musical intervals, like a fifth above or a third. Great for lead sounds, gives them real power, or even faking chords.
Right, stacking the tones. And then the waveforms themselves. Each oscillator has 6 options. This is where the character really comes in. Let's start with triangle.
Okay, triangle. The manual describes it as having a strong, fundamental, gentle, odd harmonics. Sounds smooth, right? Almost like a flute.
Yeah, very pure, clear pitch because of that strong fundamental, but soft.
Mellow, rounded. A good starting point if you don't want anything too harsh.
Then on oscillator 2, you have the triangle sawtooth mix. Adds a bit more edge.
Yeah, it brings in some even harmonics too, apparently. So it's bridging the gap. Still got some smoothness, but with a little more harmonic content, more bite than the pure triangle.
And oscillator has the reverse sawtooth. Why reverse?
It sounds pretty similar to a regular sawtooth, but the manual notes it's good for modulation. The shape of the wave, how it ramps up versus down, can sometimes give a slightly different feel when you're modulating, say, the filter. A bit more percussive, maybe.
Interesting. Okay, the classic sawtooth wave.
Hmm.
The manual calls it harmonically dense. All the harmonics are there.
Yeah, that's the big one. Your go-to for those thick, brassy sounds, fat basses. It's just full of harmonic information.
Like raw material for the filter to chew on.
Exactly. You start rips, then you carve away.
Then the pulse waves. Pulse 1 is also a square wave. Only odd harmonics like the triangle, but much stronger.
Right. That symmetry cancels the even harmonics,
Yeah.
gives it that characteristic hollow, sometimes reedy sound. Think classic synth strings or leads.
And pulse 2 is a wide rectangle, so not quite square. Even harmonics creep in.
Uh-huh. As the pulse width changes, the harmonic balance shifts. The manual says hollow, reedy, maybe a bit more nasal than the square.
Right, slightly different flavor. And pulse 3, the narrow rectangle. Even more emphasis on lower harmonics.
Yeah, very narrow pulse. Makes it sound quite thin, nasal, focused. Can really cut through.
The manual has a neat tip, too. Mixing a triangle wave with one of the more complex ones
Oh, yeah, that's clever.
to sort of highlight specific harmonics without adding mud.
Exactly. You can slightly detune the triangle against, say, a sawtooth, and it creates this subtle phasing that brings out certain frequencies in the saw. Adds a nice shimmer or movement.
Cool. Now, oscillator 3, again, that OSC 3 control switch, turning it off disconnects it from the keyboard.
Yeah. And crucially, the manual says it gives it a much wider frequency range. So you flip that switch, and suddenly OSC3 isn't just playing notes anymore.
It becomes a dedicated modulation source.
Yeah.
An LFO.
Pretty much, yeah. A wide-ranging LFO you can use to modulate pitch for vibrato or sweep the filter, all sorts of things. That's key for adding animation.
Okay, makes sense. Moving down the panel then to the mixer and noise section. Pretty self-explanatory. Balance the oscillator's noise, external input.
That's the basic idea. Volume controls for OSC 1, 2, 3, noise, and an external input. Plus those vital on-off switches for each one.
Why vital? Just for mixing?
Well, yeah, for mixing, but also really handy for tuning. You can switch off OSC 2 and 3 to accurately tune OSC 1, then bring the others in, or just isolate a sound source to hear what it's doing.
Ah, right. Good point. And the noise section. White and pink noise. What's the difference sound-wise?
White noise is, well, it's like pure static, isn't it?
Yeah.
Equal energy across all frequencies, hissy.
Right.
Pink noise has more energy in the lower frequencies, less in the highs, sounds softer, more like rushing water or wind, less harsh than white, often better for emulating natural sounds or for certain modulation effects.
Gotcha. Okay, modifiers.
Yeah.
And the big one first, the move ladder filter.
Mm.
This is like the sound, right?
Oh, yeah. Absolutely iconic. It's a 24 dB per octave low-pass filter. That's steep.
So low pass means it lets low frequencies through and cuts the highs.
Exactly. The cutoff frequency knob sets the point where it starts cutting off those higher frequencies. Turn it down, the sound gets darker, warmer, muffled. Turn it up, it gets brighter, more open.
That's the core of subtractive synthesis, basically.
Yeah,
Start rich, filter down,
you nailed it.
and the emphasis knob, resonance. What's that doing?
Okay, so emphasis, or resonance, feeds some of the filter's output back into its input. It creates this peak, this boost, right at the cutoff frequency.
So to accentuate that frequency.
Yeah, a little bit adds definition, a sort of focus to the sound, but crank it up.
It starts to scream.
Pretty much, it gets really pronounced, almost whistle-like, and if
Yeah.
you push it high enough, the filter will actually start to oscillate on its own, creating a pure sine wave tone.
Wow. Okay. And the pitch of that self-oscillation, you can control it with the keyboard using those keyboard control switches.
Right. The 13 and 23 switches, they link the keyboard pitch to the filter cutoff frequency.
So higher notes automatically open the filter a bit more.
Exactly. It makes higher notes brighter so the sound stays consistent across the keyboard. Otherwise, high notes might sound duller. The 13 or 23 just sets how much the filter follows the keyboard pitch. It's called key tracking.
Ah, key tracking. Makes sense. Okay, next modifier. The contour generators, envelopes.
Yep, envelopes add shape and articulation over time. There are two identical ones. One usually routed to the filter cutoff, the other to the overall loudness, the VCA.
Giving the sound its dynamic shape. And they have three main stages: attack, decay, sustain.
Correct. Attack time is how long it takes for the sound or the filter effect to reach its maximum level when you press a key. Zero attack is instant. Longer attack gives a swell.
Okay, then decay time.
That's how long it takes to fall from that initial peak down to the sustain level.
And sustain level is the level it holds at while you keep the key pressed down.
Exactly. So attack and decay shape the beginning, the transient. Sustain is the holding level.
And for the filter contour, there's that amount of contour knob. How important is that?
Hugely important. That determines how much the filter envelope actually affects the cutoff frequency.
Yeah.
Set it low, you get a subtle blip or wah. Set it high, you get a really dramatic sweep like, wow. It's the depth control for the filter envelope.
Got it. Depth control. Okay, moving over to the controllers and modulation section. This is where we add movement, right? Using LFOs, noise.
Right, this is about adding animation and expression. You've got modulation sources and destinations, and those two black rocker switches are key selectors here.
Yeah, the modulation mix knob lets you blend between whatever sources those switches select.
Correct. You pick two sources with the switches, blend them with the knob, and then you apply that blended signal using the mod wheel over on the left.
Okay, let's look at the switches. First one, OSC. 3 filter AG, so oscillator 3 or the filter envelope as a modulation source.
Yeah. We already talked about using OST3 as an LFO when its keyboard control is off. The filter envelope, though, the manual says it's great for brass or percussion sounds.
Why is that?
Because it has that sharp attack and decay shape built in. When you route that shape to control pitch or filter cutoff, it creates that initial punch or blip that's characteristic of struck or blown sounds. Very useful.
Makes sense. The other switch, NoIAS, LFO.
Yeah.
Choice between the noise generator and the dedicated LFO.
Right. The dedicated LFO is your standard tool for things like vibrato modulating pitch or creating rhythmic filter sweeps, like a wah-wah effect. Predictable, cyclical modulation.
And the noise, what's that like as modulation?
Noise modulation adds randomness. Instead of a smooth wave, you get this sort of sputtering, chaotic change. Good for sound effects or making things sound a bit unstable or vintage. It actually uses pink or red noise depending on the main noise switch setting.
Ah, okay. And the manual mentioned the MOD SRC jack on the top panel ties into this if you plug something in there?
It overrides the internal noise source on that switch position. So you can plug in an external CV source, maybe from another synth module, and use that to modulate things via the mod wheel. More flexibility.
Cool. Okay, let's shift to the left-hand keyboard panel. The performance controls. We've got the LFO rate knob, sets the speed of that dedicated LFO.
Yep. Slow for gentle sweeps, fast for crazy warbles, and you can pull the knob up.
Right, changes it to a square wave LFO.
Yeah.
How's that different from the default triangle?
Triangle LFO gives you smooth ups and downs, like a smooth vibrato. Square LFO jumps instantly between high and low values, so it creates more of a trill effect or a hard-on-off pulsing. Very different character.
Okay. Then the famous mod wheel applies that mixed modulation signal we talked about earlier.
Yeah, you push it up, and whatever you've set up in the controller section starts affecting either the oscillator pitch.
If the oscillator modulation switch is on.
Right. Or the filter cutoff.
If the filter modulation switch is on.
Exactly. It's your real-time control for bringing that modulation in and out. Very expressive, and it's totally analog, no MIDI involved there.
Pure voltage control. Next to it, the pitch wheel for pitch bends.
Standard pitch bend, yeah. But the manual notes, it has a center detent, a little click in the middle, so you know when you're back in tune, but it's not spring-loaded.
Oh, interesting. So it stays where you leave it.
Yep. You can do those slow drifting bends or just leave it slightly off pitch if you want. Different feel to modern spring-loaded wheels.
Then the GLIDE switch enables portamento. That's sliding between notes.
Uh-huh. And the actual time it takes to slide is set by the GLID knob back in the main controller section. You can go from a quick slur to a really long, slow sweep. Classic synth effect.
And the decay switch, what's that doing?
That's kind of neat. When it's on and you release a key, the sound doesn't just stop or fade based on the loudness envelope alone. It also makes the filter cut off frequency decay, following the filter envelope's decay time setting.
So the sound gets quieter and darker as it fades out.
Exactly. A more natural kind of decay for many sounds, where the brightness fades along with the volume.
Clever. And finally, those oscillator modulation and filter modulation switches we mentioned, they're basically the master on-offs for the mod wheels effect.
Pretty much. They decide whether the modulation signal actually reaches the oscillators or the filter. You need them on for the mod wheel to do anything to those parameters. Gatekeepers, like you said.
Right. Okay, let's just briefly touch on the top patch panel. It's not fully modular, but it adds connections.
Yeah, it's about interfacing with the outside world. External gear, other synths, pedals, expands what the Minimoog can do.
The manual highlights the external input signal jack. We mentioned the mixer knob for it. So you can run like a guitar through the Moog filter.
Absolutely. Or a drum machine, another synth, vocals, anything. Run it through that amazing filter in the VCA, shape it with the envelopes. It's a powerful way to process external sounds.
And the manual warns about feedback if you turn up the external input volume with nothing plugged in.
Yeah, because the output can loop back internally. Cranking the volume creates a feedback loop. Can sound like distortion, overdrive. Some people use it deliberately for gnarly sounds.
Huh. Okay. Creative abuse. It also mentions control inputs for oscillator pitch, filter cutoff, and loudness for external voltage control.
Right. You could plug in, say, an expression pedal to control the filter cutoff with your foot. Or sequence pitch externally. More hands-free control options.
And that MOD, SRC, IMPUT jack we discussed, overriding the internal noise for modulation, it just opens up more possibilities.
Exactly. Flexibility is the name of the game there. More ways to shape and animate your sounds.
So wrapping this up, it really feels like understanding these core pieces, the oscillators and their waveforms, that incredible filter, the envelopes for shaping, and all the modulation options, that's the key, isn't it?
Absolutely. Once you grasp how those blocks connect and interact, how the oscillators feed the mixer feeds the filter, the envelopes and LFOs shape the filter and liveness, you can start building pretty much any sound you can imagine.
Yes, seeing it as that signal flow.
And for everyone listening, we really hope you'll take these ideas, maybe picture that signal path. If you have access to a Minimoog hardware or software, start tweaking, understanding that flow is step one.
Definitely. So here's something to think about. The Minimoog is famous for its leads and basses, but its design is so, well, intuitive. What weird, surprising sounds, what unexpected textures do you think you could discover just by playing around with these controls in maybe unconventional ways? Maybe check out some performance tips and see where it takes you.